Hello, everyone. Welcome to an episode of Quirkcast. This is your host, Tim.
And I'm Mikey.
And this is Sahil. Welcome everybody to a brand new episode of Quirkcast. Before we get started, few mentions of few guilt tripping things that I typically say at the beginning of the episode. If you haven't already, join our Discord channel so you can match with us there if you haven't already. And if you're watching this on YouTube, please do post comments and questions so we can get to them during the episode. And if you listen to this on podcasts, do give us a rating and review on Apple, Spotify, or wherever you listen to your podcast. Those would be immensely helpful. Any feedback. So without further ado, so I guess Tim or Mikey, I was thinking about the deep philosophical question that a lot of people ask, like, is there free will? Is there determinism? And I thought, like, when I decided to do something, like, I don't know how I decided to do it. And I understand, like, get very deep into it. But what does physics have to say about free will and determinism, or either one?
Maybe we should go and try to define these notions first, because I think, as we'll see, the way we decide to define determinism and notions like that kind of play heavily into what the answer to this question is. But I guess just at a most basic level, this argument kind of stems from like a battle between two titans in the early 1900s, like Einstein versus like the quantum mechanists like Paul Dirac and Erwin Schrödinger, who and basically, like, Einstein kind of believed that the universe was kind of like a set of billiard balls. Like, you hit it with exactly the same angle, it goes in exactly the same way every single time you do that, and that this was repeatable. He called it the clockwork universe. It's just like, you can literally imagine there's a bunch of gears where one turns, and that has an exact and absolute effect on what happens like further down the chain. And this kind of universe, it means that if you had a sufficiently powerful computer, you could and you had the positions and locations of all the particles, you could just like play the tape forward and, like a simulation, and just predict everything that would happen. And this made Einstein feel very comfortable. On the other side of that argument were the quantum mechanists, who were discovering these new kind of phenomena about nature that seemed to imply that this is not a fundamental property of our universe, that it's like fundamentally random or probabilistic. So that's where the argument kind of came from between determinism and non-determinism, which one is more fundamental, and how does that affect free will? I think that's even more difficult, because now we're like folding psychology into the mix, and that's where it gets a bit murky. I don't know.
Yeah, I think I want to mention the kinds of determinism that we people colloquially talk about. And I think that's slightly different from this very technical kind of physical, these theorists talk about determinism at the fundamental level. So it's sort of like, when we think about determinism, it's very relatable. It's like, imagine today I went to the grocery store, I got some lettuce as opposed to spinach. And I'm kind of wondering, like, did I actually have a choice? Was I going to get lettuce anyway? Or did the universe make me get lettuce versus maybe I had a choice? I could have been like, hey, I wanted to get spinach instead of lettuce. And like, in every step of our everyday life, I think people often wonder, like, if we made a mistake, we make some good choices, bad choices, and we sort of ask the question, like, hey, maybe there's sort of this all-powerful reaching hand to make me do this because of maybe some determinism principle, so that kind of resolved me of responsibility of doing things, right?
Well, wait, it doesn't have to be an all-powerful hand, right? Like, I mean, like, I went and got the groceries today and decided to get spinach. I saw a YouTube video yesterday talking about how spinach is good for me, like, and that has a direct influence. But is it possible that despite seeing that video, I could have chosen, to get, lettuce instead or whatever?
Right. Yeah. So that kind of determinism is very much an emergent phenomenon, obviously, because people are made of huge number of molecules, and so determinism on that level, it's a bit of a separate concept, right? So let's just take a step back on that. Like, even if like even if the universe is perfectly predictable, what Einstein thought, like billiard balls, A goes to B goes to C. Even if that were true, still, if the experience could be constructed in such a way that we don't necessarily perceive determinism, right? Even though at the fundamental there might be. The emergent phenomenon could be that it might be like highly difficult to predict what happens next, and as a result, it feels like we really have a choice to choose spinach or lettuce, right? So that's sort of two separate issues there, I think.
Yeah, I think basically what Tim is saying, correct me if I'm wrong, is that a huge amount of complexity can easily manifest in something that looks like free will, right? And that's a separate question.
Right, yeah.
Does this mean if I had like a sufficiently powerful, let's say, classical computer, just store like almost a near, for all practical purposes, near infinite amount of like, processing power and storage, could I figure out what my future would be like in that sense, or is it still difficult?
Well, I would say that question is a bit independent of whether fundamental physics is deterministic or not. It's a bit separate. Like even if the universe is fundamentally deterministic or not deterministic, there's still this gap between using those physics to describe, like to sort of predict the future, basically to say, hey, what am I going to do tomorrow? Is it predetermined or not predetermined, right? And it could go either way, I think. And of course, I think the answer is no right now, because like most people cannot predict what's going to happen tomorrow. Like we don't know if the stock market is going to go up or down, because if that were to happen, someone's going to be a billionaire. I don't know, right? Or like in poker games would be very silly now. Like everyone can see their cards. But like, oh, I know what my opponent has. Like, who cares, right? And then the games would be very silly. So clearly, like on the emergent level, we have some notion of indeterminism, and that's undeniable, right? Regardless of the physics, this level of indeterminism is true. It's an emergent phenomenon, right? That much is true. But I don't think we want to go too deep into that, because that doesn't have too much to do with fundamental physics. It has to do with physics, but like not fundamental physics.
Gotcha. Before we go on, can you explain for the audience what emergent means when you mention it multiple times? Just want to clarify the definition of that.
Yeah, I think emergent level on a colloquial level, like Mikey was mentioning, basically means that if you can have very simple laws, simple constituents, but when you mix them up together, and you have thousands and billions of interactions between these simple objects, and then very complicated behavior emerges. It's almost like the sum is much, much, much greater than just the sum of the individual. Like something very much more complicated emerges. Like for example, you can look at ants. Ants are really kind of dumb creatures in some sense, right? They don't have higher function, but they can coordinate to build great structures like ant nests and like bridges when the water floods. And it's not because the ants have some sophisticated brain, but because they have these little coordination tasks that they're familiar with, and somehow together they create these complicated structure, right? In the same vein, there are many other examples, right? Like snowflake is another example. Simple molecules can give you very intricate looking sophisticated structure, and like the human mind, the brain, and all that. So those are all emergent phenomenon. So you can't just reduce the behavior of the emergent system by the sum of the constituent. It's not enough, right? So I don't think we're going to attempt to do that to some extent.
So emergent phenomena means teamwork.
Right. That's a nice way of putting it. Yeah.
Or effective teamwork, right? Otherwise, if it's just everybody doing their own thing, it may not work.
Yeah, definitely no emergent behavior there.
Yeah. So going back to this, I guess like, what would it mean if if there were in principle deterministic laws? I mean, how's that compatible with quantum mechanics? Like we've been talking about classically or large scale, but what about at the small scale? How does that mix together?
Yeah, I think to do that, we first have to define, like, really, because we talk about the emergent way of defining determinism. I think we still have yet to discuss what it means for something to be deterministic fundamentally. And that's very tricky. I'm not sure if there's a clean definition, is there? Mikey, what do you think?
Honest, I'm confused on this subject. Oh gosh, it's one of those things where they say, like, you know, you think you understand and you realize you don't understand. You go through this like iterative procedure of like
Yeah, but as a physicist, I think I like to think of something procedurally. Like when I first in high school learned about the scientific method, you can argue that science is defined through experiments. So I think one fair definition, and I don't mean this is the ultimate definition of determinism, is through experimentation. Like whenever people say determinism, they're kind of in their head imagining what if a scenario were to repeat itself, right? Like imagine, hey, I went to the grocery store, I decided to buy lettuce, right? And if you were to ask, hey, is there determinism? I would kind of imagine, hey, if the exact situation arises, I went to the grocery store again, am I going to get lettuce again? So in that sense, determinism could be described as if the same system, all the configuration were to present itself in exactly the same way, everything exactly the same, will the same outcome be observed? But I think that would define what determinism is in sort of in a fundamental world, right?
If you say it that way, the concept of free will sounds very arrogant, doesn't it? It's like, like, okay, everything happens in exactly the same way around me, but just me, I have the power to like make things somehow go differently for everybody else, right? That's ridiculous. Like to say that, like, okay, so let's say I saw like 100 YouTube videos that told me that lettuce was healthy. And, you know, I'd grown up, well, okay, it goes back to like nature versus nurture. Now we're getting into that conversation that we said we didn't want to have. But I don't know, I guess I just wanted to know kind of the hubris of like that interpretation, that I have the power to like overcome any kind of environmental factors that might lead me to some decision. It's kind of like, you know, pervading the undertones of this free will argument, isn't it?
I could see that. I guess like I do think there's a lot of hubris in thinking like it's complete free will, because that ignores the influence that the environment has on me if I believe in true free will.
Oh yeah, yeah, that's good to know.
But I guess the problem is, what is the unit of free will? I guess the most sensible thing is every fundamental constituent, right? It's like they all have the power to decide for themselves. Like maybe that's a fair definition, whether fundamental constituents have the power to determine for themselves, each one of them.
I mean, in a sense, we're decision machines, right? So we look at the past accumulation of how many YouTube videos we saw telling us to buy lettuce and all that other stuff, and it goes into some calculator. So in that sense, you know, if we're decision-making machines, then that capability endows us with what we call free will, right? What's the argument against that?
Yeah, well, I mean I think that's the issue between the emergent and the constituent. Like if you follow Einstein's, like if you go back, what is it, early 1980s, whatever, don't remember the year, when this debate happened between sort of the classical physics and the quantum mechanical community, you can say, hey, like, give me each fundamental constituent and ask, do they have the power to kind of determine for themselves, right? Decide where to go. I guess Einstein's camp would say that no, it's just every particle has just one predefined trajectory. It just is, right? There's no alternative. And then the question is, well, if that were true, and you argue that a person is basically a sum of these tiny fundamental constituents who don't really have a say on where they go, then if you say that the sum is just little, you know, the whole is just the sum of the constituent, then you argue that a person, because the constituent of a person does not have free will, then the person would not have free will, right? And then in the same vein, if you go to the quantum mechanical camp, the quantum mechanical physicists would say that, hey, each individual particles, their trajectory are ultimately undetermined. They're random. There's quantum mechanical fluctuation fundamentally. And then in the same vein, and then because these particles, I guess, I don't like to use this word, have the power to determine for themselves, but it's not like they're trying to, but like they can fluctuate because this person is the sum of the whole, and none of them has any determinism. Then you would argue that the person sort of it's non-deterministic, right? Has free will, thus, right?
Wait,
so
wait. Sorry, this free will argument is confusing me a bit now, because
I mean that's a naive argument, right? Like if you say the person is the sum of its constituents, and just look at the behavior of the constituents, whether they are
these constituents that make up my particle, at least, are directly influenced by my previous history, right? So if you say that I'm a decision-making machine that makes decisions based on my unique history and what I've experienced and what I, my trials and tribulations, so to speak, then isn't it my free, like, if I choose lettuce at the grocery store, I'm proud of that decision because it's based on all of my experiences, and that's very unique. It's based on the world lines of all the particles that make up my brain, right? Does that negate the idea of free will? To say that I couldn't have just become like a different person, like to make a different decision, wouldn't that require me to like have become a different person in a sense? And isn't that not a free will argument question anymore? It's like, would someone with different tendencies that looks like me choose spinach instead?
That's a hard question to answer. I mean, you would need like a control group, right? Like a counterfactual, like a universe in which something got modified.
Yeah, so I would say if you go through these like basic arguments like I laid out, and obviously Mikey, your counterpoint is valid, right? Like in order for me to really talk about these two comparisons fully, I have to take into account the history of all particles that does all these interactions, go all the way to the beginning of the universe. And it's like Carl Sagan said, I have to recreate the whole damn universe to even talk about it. And then you just go into the rabbit hole, right?
And that's impossible, right?
Yeah, but that's the kicker. It turns out that quantum mechanics actually give us a way out, because it's impossible. You actually cannot do that because quantum physics tells you that you actually cannot gather all those information and kind of trace all of them. So it's almost like it doesn't really matter how you interpret quantum physics. You can interpret quantum physics as some deterministic law, but you just lack the knowledge to construct all the bits and pieces and the paths of the particles. Or you can think of quantum physics as a completely non-deterministic law, just random jigglings here and there, just rolling of the dice, like Einstein said, just playing dice all the time with God and just whatever goes. Like those are irrelevant, actually. There's no way for you to find out, even in principle. There's no way for you to repeat the experiment. There's no way for you to reconstruct the situation. There's no way for you to go back to the store, have the exact setup, and have to choose lettuce and spinach again, because every instance you do that, it's new, right? Even if you choose lettuce 10,000 times out of 10,000, they're not the same situation. So there's nothing you can say about what happened in the past. So I don't know, where does that leave us? It seems like
it seems like it's you can't even determine it in principle. So on our previous episode, if you can't determine in principle, does it exist? I ask you that, Mikey. Does determinism exist if you can't do it in principle?
I think the answer is definitely no, because I think I'm married to that as like a hard theorem of physics. Because it's just very quickly, like it's not just like oftentimes the things that we find are not discoverable in principle. Thank goodness. Otherwise, all hell would break loose, and the laws of physics would be contradictory. That's like, if you assume that things outside of like events outside, what you can see by according to the speed of light can be accessed, then all hell breaks loose. The laws of physics and the whole structure comes crumbling down.
I suppose this is interesting. It's not just that it's a hard no. It's almost that this concept doesn't make sense. You're not asking the right question. Like, you shouldn't be asking whether there's determinism, because you can't define what determinism is.
It's not the same as computability. It's not like if I were to like try really, 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 really hard to come up with the most perfect theory, there's no way I could test this.
Because there's no experiment, literally, that you can do to actually test, determinism or not. There's no concept in which that's experimentally verifiable. I think that's true, right?
Is it because it's not like, I mean, I guess repeatability is not there, right?
Wait. Let's before we continue on this, let's go to why, in principle, it's impossible to do this experiment quantum mechanically. Because I think there's actually a loophole in that argument. I guess the argument goes something like, okay, if I was in exactly the same situation, then would I make the same decision? And if you could recreate that same situation, then would it go the same way? And generally, the no copy theorem prevents you from being able to do that experiment. But okay, sorry, never mind. I take back what I said.
Well, I mean, the no cloning theorem, for those listeners who are unfamiliar, means that you cannot have a quantum machine that copies one state to another. Basically, you cannot repeat the experiment exactly, right? And then you can argue, well, maybe we can try to get close to see if the closer we are, the closer to determinism there is. But I guess that's the closest thing. And even, the thing is, in quantum physics, we know that the prediction of an outcome can be approximated by probability, right? So that itself denies, that itself falsifies the most basic notion of determinism, right? But there's a different level of determinism, okay, that I want to bring out, and this is the determinism of emergent behavior, right? You can argue that, hey, just because, okay, so this is a thought, right? So you can argue that, hey, if the constituents are not deterministic, how is it possible that the outcome, a microscopic construct can be deterministic, right? It seems unintuitive, but it could actually happen. Like, imagine you have 10 trillion dice and you just roll them, and you can say, hey, on average, what's the average value of a dice roll, right? Even though each die is completely random, on average you approach some average value. It's like 3.5, right? So it's possible that actually the constituent might be non-deterministic, but then the outcome could be approximately deterministic, right? So
that blows a hole in anyone who thinks that like quantum mechanics is like the consciousness arises from, right? Like the fact that you need like the fact that if you have some source of indeterminism microscopically, that has to be the source of all indeterminism macroscopically.
Yeah, that's not right. Yeah, that's not necessarily true. So I guess what I was trying to say is that, so exact determinism, it's totally not well defined. You cannot define it because you can never repeat an experiment fully. But approximate determinism Oh yeah, sure. We can define it. And in fact, that's what drives scientific experiments, right? Like certain things are deterministic to some degree. If you prepare experiments in certain ways and you perform certain experiments, it will go a certain way. Like if you poke a billiard, or you hit a billiard goes one way and it will go at a specific angle. You can test this, right? So
I think the analogy is that if I went to the supermarket determined to buy just one thing and it turned out to be lettuce, it's not likely it would be like a steak.
But what about like more social phenomenon that is macroscopic? So say like markets. Let's say I build some model that predicts the market and I start using that model. The market will change its behavior in order to adapt to my new strategy. So there's this like, I think in the realm of social science is a little bit trickier. I'm curious if you guys have any thoughts on that. Or
I mean, the markets are chaos, right? And it's also like there's a feedback mechanism which makes it like adaptive, and it actually favors chaos in a sense, right? Because arbitrages disappear naturally if you follow the doctrine.
yeah. Well, yeah. So it's interesting. So Micah, you bring up this concept of called chaos, and now we're totally in this totally opposite realm of determinism, right? We forget about the fundamental constituents, just throw that all to the trash, forget about it, right? When you talk about these emergent behavior, emergent phenomenon, the system is so large that just using the physics of the constituent doesn't help you very much, right? And the idea now is to see if there are patterns emerging from chaos, what Mike was saying, right? Chaotic systems are basically systems that are evolving so fast, they almost appear random, and they also...
It means that the fundamental drivers are completely obscured, right? Now you're
basically, yeah,
these emergent laws that have almost no direct bearing of like the fundamental properties.
Right, yeah, and it's like perfect scrambling, basically, perfect scrambling, as scramble as possible, just like the roll of the die example. And in this situation, it's actually very interesting now. So certain things are highly non-deterministic. Like if you have a 10,000 dice and you look at the row of each individual die, you'd be like, well, I can't determine that. But then the overall trends of the average of a die row, that's deterministic. That becomes more and more deterministic now, the more samples you have. So I think in social science, I think that's exactly what's happening, right? Like there's some broader trends that, that what people tend to do, like, maybe there are percentage of people who tend to buy lettuce over spinach. Like that's, who's to say that's not some level of determinism, right? And
mine's advertising.
Yeah, basically. And you can argue the financial markets. There's certain bits that are not deterministic because these are kind of too sensitive to the microscopic fluctuations of the microscopic indeterminism, right? Like the role of the individual die, like, or the price of a stock, because it moves so much. But yeah, so I guess at the end of the day, yeah, determinism is not, it's not 0 or 100%. You can't, it's ill-defined. The only well-defined quantity of determinism is somewhere in the middle, kind of.
Does that mean like you have a certain statistical expectation of what's to happen, and if you repeat an experiment and it comes close to that expectation, then it is approximately deterministic? Is that a fair statement?
I think that is the summary, and also going one step further than that the, like I mentioned at the beginning, it really depends on how you define determinism. If we define it in the careful way that you just described, then it can make sense, and we can say that the universe is approximately deterministic. But if we ask it in this kind of artificial way that it's often posed, then it just kind of stops making sense. And I think this is a function of the artificiality of the question.
Yeah. Well, so we're basically at time. Anything else you guys want to say before we head out?
Yeah, I would say, unfortunately, we probably didn't satisfy any philosophers questions about determinism, and quite the opposite. We basically just told the audience that asking this philosophical question about determinism doesn't really make sense. Determinism really is a human thought. Basically, it's a human thought experiment, and in order to connect it to the real world, you have to quantify it. And the moment you quantify it, it becomes, I guess, almost more boring now, more vanilla. And the moment you do that, you can start doing calculations. You can look at emergent systems. You can look at quantum mechanical behavior, and then you can ask the question, to what degree of determinism a system has. Now that becomes a legitimate question, and then the answer is it's not black and white. It just depends on the situation, and it's just, I guess that just is how physics works. So,
yeah. Anything else you want to add, Mikey? Or
I kind of want to end with something that I'm confused about that I hope to at least tackle you both about after this is over, which is, if you assume that the whole universe is a simulation on a quantum computer, right, then how does this argument play out? Because it's not because quantum circuits are deterministic in a sense, right? Maybe this is something we could tackle in a future episode. Maybe it's something we could.
You mean quantum determinism? That's even more vague, I suppose.
It's a little more precise in a sense, because right, it's talking about the evolution of the state of the universe, right? And that's kind of a deterministic thing, and why collapse of wave functions, which we didn't get into, and things like that seem to appear in this framework is a little bit confused in my head. But anyways, this may or may not be the topic of the future episode.
we could save that for another episode. I would just probably change the word slightly from deterministic to computable. But yeah. So without us going down this rabbit hole, we'll use this as like a fishing hook for the set of people to come in and listen to us talk about this. All right. So on that note, I want to thank everybody for joining us, and we'll see you all next week.
Yeah. See you all next week. Maybe it's predetermined. Think about it. Bye.